Hello, this is a GATE syllabus and this is for engineering mathematics. This syllabus is for engineering mathematics and for GATE exam. This syllabus is taken from the mechanical engineering branch, but this syllabus is almost applicable for all the branches. Just go through the syllabus. Here you will see the main component of engineering mathematics is linear algebra, calculus, differential equations, complex variables, probability and statistics, and numerical method. To score very well in the GATE exam, you have to prepare only these topics. If you prepare very well, you can score very well. So you should concentrate on only these chapters. First of all, I will teach you linear algebra. So this is a most important chapter in engineering mathematics. In linear algebra, you have to read only matrix algebra, system of linear equations, eigenvalues and eigenvectors. Okay, nothing else. You have to read only what is matrix algebra, system of linear equations, eigenvalue and eigenvector. Okay. So in linear algebra, the first topic was matrix algebra. So I will explain you about matrix algebra. Matrix algebra. So to know matrix algebra, you first know what is the matrix is. Here is the example. The first thing is that matrix is notated by a capital letter. Suppose this is a matrix. A is a notation, and here is a matrix. Here is the example matrix. I can take any random number. Suppose 1, 2, 4, 3, 8, 9. So this is a matrix. So this is not a determinant. You first understand this. Any digit cannot be changed to any other place. Every place and number is very significant for the matrix as a whole. So this matrix is composed of all these values as well as positions. You cannot change the position of any number. So this is a set of numbers. Basically this is a group of number, and this whole group of number is treated as single unit, and it is called matrix. So every matrix has certain fixed principles, certain fixed characteristics. You will go through all. So first you should know that the type of matrix. So a type of matrix means what is the number of row and what is the number of column of this matrix. So here you can see that this matrix is having 3 row, 1, 2, 3, and 2 column. So A is 3 into 2 type of matrix. So first comes row, number of row, and the second is number of column. So this is a 3 into 2 type of matrix. Suppose another matrix B. This is 5, 6, 9, 2, 3, 1, 4, minus 8, 2, 6, 1, 9. So this is another matrix which is denoted by B. Here the number of row is 3 and number of column is 4. So B is number of row is 3, number of column is 4. So 3 into 4 type of matrix. This type of matrix. Number of row is also denoted by M. So here M is 3, and number of column is denoted by N. So N is 4. So B is M into N. Here M is 3, N is 4. Here is another example of matrix. Suppose I want to denote this matrix by C. It is 1 4 5 4 2 8 9. So this is a matrix C, and it is the matrix is this. Any element of this matrix can be denoted by it is identified by first which row this column this element is and which column this element is. So C3 C2 1 C2 comma 1 is equals to how much? 9. Similarly C1 3 is equal to C1 3 means first row is this and the third column is this, so element is 4. C1 3 is 4. So this is basically a notation of any element of a matrix. Here I will explain you about row matrix. Row matrix, what it is. If any matrix is having single row, then this is called row matrix, means 3 5 9. Here in this matrix what you see? Single row. Number of element can be anything, but the row is single. Row is only one, so it is a row matrix. Another example is 1 5 minus 2 9 4. This is the row matrix. In any matrix, number of row or number of column can be anything, but in row matrix the number of row is column matrix. In the column matrix, the number of column is only 1 6 5. It is a example of column matrix. Here in a single column the number of element can be anything, but the number of column is itself 1. It should be only 1. This is called column matrix. Okay, this is a column matrix. What is a square matrix? See, in a square matrix the number of row and number of column is same. Here is the example: 3 8 9 5 6 minus 5. So in this example what is the number of row is 3, number of row is 3, and number of column is also 1 2 3 3. So you can see that m is 3 and n is 3, and m is equal to n. Number of row and number of column is same, so this is a square matrix. So this is a square matrix. So now I will explain you what is the diagonal of matrix. So here is it. See, the diagonal, first you start from the first element, it is this, then middle and then corner, means make it diagonal, and then whatever the element is, all this element is called diagonal element. So diagonal element is 1 8 and minus 9. What is diagonal element is? Diagonal elements are 1 8 and minus 5. So if you know what is the diagonal element, you can also know the trace by the diagonal element. So trace of matrix is nothing but this is a sum of diagonal elements. So in this example, the trace is equal to how much? Trace is equal to 1 plus 8 plus 1 plus 8 minus 5. 9 minus 5 is equal to 4. So trace of matrix is 4. If anybody asks you what is the trace of matrix, then you just add the diagonal element, you will get the trace of matrix. Remember this. Okay, so here you just add 1, 8 and minus 5, diagonal element, trace of matrix is 4. Now I will explain you singular and non-singular matrix. What is this? Suppose a square matrix. A square matrix can be of two types. One is called singular matrix and other is called non-singular matrix. Here is any matrix, any square matrix. So first of all, matrix should be square. Once it is a square matrix, it can be either a singular matrix or it can either be a non-singular matrix. So what type of matrix is what type of square matrix is a singular matrix? Okay, so if the determinant of that square matrix is 0, then that type of matrix is called singular matrix, and if the determinant of that square matrix is non-zero, then that type of matrix is called non-singular matrix. So see, so for singular matrix, take a example of a square matrix A B C D E F G H I. So this is a 3 by 3 matrix, and it is a square matrix if the condition is determinant of that matrix is 0, then this matrix is called, suppose A is this. So A is, if the determinant of A is 0, then A is singular matrix. If the determinant is not 0, means this is not 0, then A is non-singular matrix. Okay. So singular matrix can be only if the determinant is 0. So first condition is determinant should be 0, then matrix will be singular. If the determinant is not 0, then the matrix is non-singular matrix. Now I will explain you diagonal matrix. Diagonal matrix. The first condition for the diagonal matrix is it is a square matrix. First of all, it should be square matrix, and only diagonal element. Here is the example: A is equal to, suppose A, B, C, and all other element except diagonal is 0. So you can see this is the diagonal element ABC, and A is not 0, B is not 0, C is also not 0, but all other element is 0. So that type of square matrix, of which diagonal element is not 0, and all other element is 0, then this type of matrix is called diagonal matrix. A is called diagonal matrix. Once you understood what is diagonal matrix, you can easily understand what is the unit matrix. So here it is. What is the unit matrix? In the unit matrix, A is equal to B is equal to, in the unit matrix, A is equal to B is equal to C is equal to 1. If all the diagonal element is 1, then that type of matrix is called unit matrix. Here is the example: 1 1 0 0. So first of all, this is a square matrix. The second point is that it is a diagonal matrix where only diagonal element is not 0 and all other element is 0, and the third condition is that all the diagonal element is 1. Then this type of matrix is called unit matrix. It is denoted by IN, where n is the number of row and number of column. Here the number of n is 2, because number of row is 2, number of column is 2, so this is I2. Similarly, three element unit matrix can be something like this. So I3 means a unit matrix of order 3. In this I3 is, so 3 row 1 1 1 0 0 0 0 0 0. So in this you see this is a square matrix. Only diagonal element is not 0 and all other element is 0, and all the diagonal element is 1, and number of row is m is 3, n is 3, so order is 3. So this is a I3. This is a unit matrix. Now some type of square matrix. A square matrix can be, some of the matrix can be of a symmetric matrix, and some of the square matrix can be of skew symmetric matrix. So I will explain what is the symmetric matrix. Okay, what is the symmetric matrix? So symmetric matrix is such type of square matrix where Aij is equal to Aj. What is the meaning of this? Means across the diagonal element, the elements are mirror images to each other. Here is the example. I can explain you in this. Suppose A is a matrix 3 6 2 6 2 1 9 2. This is the diagonal, and every element should be mirror images. So here you can see 3 1 1 and 9. So you can see that in this matrix diagonal elements are 3 2 9, and across this diagonal element, this is a mirror image, this is a mirror image to this, this is the mirror image to this. Here is the example. Take any element. What is the condition for the symmetric matrix is Aij is equal to Jai. So suppose this is, what is this? How you can show this? A number. What is the place of this? First row and third column, A31. So what is it? It is equal to 2. So opposite of this is A31. What is the value of this? 31. Third row and first column, third row and first column, 2. So what you see here, A13 is equal to A31. So this rule is applicable for this all the elements. So this is called a symmetric matrix. This is the symmetric matrix. Okay, the symmetric matrix can only be can be made by square matrix. So this is the example of symmetric matrix. Now I will show you skew symmetric matrix. Skew matrix. So what is the first condition? It should be a square matrix. What is the other condition? The other condition is that a diagonal element should be 0. So the first condition is, what is skew symmetric matrix is first condition for the skew symmetric matrix is diagonal elements is equal to 0, and the second is aij is equal to minus a ji. Okay, negative. In the previous what I saw is that the value is same across the diagonal element, but here it is negative to the other counterpart. So here is the example. Suppose I want to make a 4x4 square matrix. 0 minus 1 0 minus 2 minus 6 minus 2 2 0 minus 6 sorry 5 okay, so 3 6 and 0. So here it is a square matrix 4 by 4, and what you can see is that the first condition is diagonal elements are 0. So in this square matrix you can see all the diagonal element is 0, and the second condition is that all the element across this diagonal element is negative to each other. So here you can see 1 minus 1 minus 2, so this is plus 2 minus 2, so this is plus 2 3, so minus 3 minus 6 to 6 to minus 6. Okay, aij, suppose I am taking this element. What is the aij? Suppose this is a so a number of row is 2 and number of column is 3, so a to 3. So I just want to it is equal to 2, so a 3 to equal to how much? Third row and second column minus 2. So you can see that this so this condition is fulfilled. So this matrix is skew. This matrix is a skew symmetric matrix.